This lecture will cover the CFA Level 1 reading on probability concepts. Let's start with a few definitions. A random variable is an uncertain quantity or number. Classic example is when you toss a coin, whether you get heads or tails, that's a random variable. So the possible values of the random variable are heads, tails, or when you roll a die, the number that you get on top is the random variable. An event is a single outcome or a set of outcomes. So again, if you roll a die and the event that you get a 1 is an outcome, you might also say that another outcome might be defined as getting even numbers. Mutually exclusive events are events that cannot both happen at the same time. So here again, if you roll a die, you can say that getting a 1 and getting a 2 are mutually exclusive because you can't get both a 1 and a 2 at the same time. Exhaustive events are those that include all possible outcomes. So continuing with the rolling a die example, getting a 1 or a 2 or a 3, 4, 5, 6, these are all the possible events, and we can say that these 6 events are exhaustive. More specifically, we can say that these 6 events are mutually exclusive and exhaustive. The two fundamental properties of probability. One is that the probability of any event has to be between 0 and 1. So mathematically that's written this way: 0 less than or equal to probability of event less than or equal to 1. For a set of events that are mutually exclusive and exhaustive, the sum of probabilities is 1. So in the rolling a die example, the probability of getting a 1 is 1/6, probability of getting a 2 is 1/6, and so on. If you take all 6 events which are mutually exclusive and exhaustive, the sum of those 6 probabilities will be equal to 1. From a CFA perspective, it's important to know these basic definitions. Empirical probability is one type of probability which you arrive at by analyzing past data. So a small example of this would be that if you are evaluating stock XYZ and you notice that over the last 100 months the stock has been up 55 times and down or the same 45 times, then you can say that empirically speaking, based on past data, the probability that the stock will go up next month is 0.55. So this probability, when you come up with a number or a probability based on historical data, we would say that this is a empirical probability. A priori probability is calculated by using formal reasoning and inspection. A small example here would be that you can say that, again, let's continue with XYZ stock. You can say either it will go up or it will go down or it will stay the same. And you say that there are 3 possible outcomes, and I am just going to assign a probability of 1/3 to each outcome. Here we have applied some formal reasoning. Now you might not necessarily agree with the reasoning, but nevertheless some reasoning was applied, and when we do that we call this an a priori probability. Subjective probability is less formal and involves personal judgment. So I might say that again, XYZ stock, there is a new CEO with a very good reputation, and in my personal judgment, because of this new CEO, the probability of the stock price going up is very high. So I indicate that in my opinion the probability of the stock going up is 0.7. Since this is based on my personal judgment, we would call this a subjective probability. This is subjective, and by that token we can say that empirical probability and a priori probabilities are objective probabilities. Odds for or against are normally associated with gambling, but since this is part of the CFA course, let's just understand the basics and specifically the link between odds and probability. Let's say that the probability that the stock market will go up is 40%. This means that the probability that the stock market will not go up is 80%. The way we express this as odds, so odds of the stock market going up would be 0.2, which is this probability, divided by the probability of the stock market not going up, which is 0.8, which is what we get from here. So we can then say that the odds for the stock market going up are 1/4, and the odds against are so this is the 0.8 divided by 0.2, so odds against are 4:1. Now if you were to solve this the other way around and you were given that the odds of the market going up are 1/4 and you are to determine the probability, all you need to do is say that the probability simply becomes 1 divided by 1 plus 4, which is equal to 1/5. A few more definitions now. What's an unconditional probability? The unconditional probability of event A, written as this, is the probability of an event regardless of the outcomes of other events. So if we refer to probability of a recession is 0.5, this means that the probability of a recession is 0.5, and this probability does not depend on any other events. A conditional probability, written as probability of A given B, is the probability of A given that B has occurred. So we might say here, what's the probability of a recession given that there is a interest rate increase? Dependent events is when knowing the outcome of one event tells you something about the probability of the other. So we might say that the event of having a recession and the event of a possible increase in interest rates are dependent on each other, because knowing the probability of an interest rate increase tells you something about the probability of whether or not there will be a recession. Independent events, this is where the occurrence of one event does not influence the occurrence of the other. So if you flip a coin, you might get heads or tails. Then you flip a coin the second time, you again might get heads or tails. These two coin flips are independent because knowing the probability of this does not impact that. Similarly, let's say the probability that it rains tomorrow versus the probability of the stock market goes up. So these two are also independent, because knowing the probability that it will rain tomorrow will tell you nothing about the probability of whether the stock market will go up. Joint probability. The probability that both of two events will occur is called their joint probability. So this is an important formula that you should put on your formula sheet. The probability of A and B both happening is equal to the probability of A given B times the probability of B. Now let's continue with the interest rate and recession example. So if you know that the probability that interest rates will increase, written as PI, is 50%, and if you know that the probability of recession given a rate increase, written like this, is equal to 70%, then using the joint probability rule, the probability that we have a recession and an interest rate increase is equal to the probability that there is a recession given an interest rate increase times the probability of an interest rate increase. So which is 0.5 multiplied by 0.7, which is 35%. What's the multiplication rule? If joint probability of two independent events, so basically this rule is that the joint probability of two independent events equals the product of the individual event. The way you can look at this is as follows. So as we just studied, probability of AB was equal to probability of A given B times probability of B. This is what we just saw. If A and B are independent, then probability of A given B would simply be probability of A. Since A and B are independent, knowing something about B tells you nothing about A. So this simply becomes probability of A, and hence probability of AB is probability of A times probability of B. So on the roll of two dice, the probability of getting 2 4s, since the two rolls are two events here are independent, the probability of getting 2 4s would simply be 1/6 times 1/6. Take another example. If 60% of recent quarters the earnings per share for a stock that you are tracking has increased, and in 40% of recent quarters EPS has decreased or stayed the same. If EPS for second quarter was larger than EPS for first quarter, so this is also given, what is the probability that EPS decreases or remains unchanged in the next 2 quarters? Now, assuming that what happens in every quarter is independent, let's say that the probability of remaining unchanged, as we've seen here, is 0.4. So since these two events are independent, the probability of the same thing happening in 2 quarters is simply 0.4 times 0.4, which is equal to 0.16. Now let's look at the additional rule for probabilities. The probability of A or B, which means the probability of A happening or B happening or both A and B happening, is equal to probability of event A plus probability of event B minus the probability of A and B both happening. And let's look at an example. Let's say that the probability of interest rates going up is 0.5. The probability of a recession is 0.4. Notice that these are both unconditional probabilities. And the joint probability of both interest rates going up and a recession is 0.35. Then what is the probability of I or R? So this would simply, so probability of interest rate going up or a recession would be equal to the probability of interest rate going up plus the probability of a recession minus the probability of both interest rates going up and having a recession. Plugging in the numbers, we have 0.5 plus probability of a recession 0.4 minus 0.35, which gives us 0.55. If we are talking about two events that are mutually exclusive, then notice that probability of AB would become 0. So our addition rule would simply be probability of A or B is equal to probability of A plus probability of B. Take another example. Let's say that you are placing limit orders to buy a stock, and the probability that order 1 will execute is 0.35. The probability that order 2 will execute is 0.25. The probability that both will execute is 0.25. What is the probability that either order 1 or order 2 will execute? So the way you can see this is probability that order 1 or order 2 will execute is equal to the probability of order 1 plus the probability of order 2 minus the probability of order 1 and order 2. So plugging in, probability of order 1 is 0.35. The probability of order 2 is 0.25 minus the probability of both happening 0.25. So this answer is 0.35. What is the probability that order 2 executes given that order 1 executes? So here we can use that formula, probability of A B is equal to probability of A given B times probability of B, and we are trying to find the probability that order 2 executes given that order 1 executes. So let's say that A is order 2 and B is order 1. So just plugging in. So probability of order 1 is simply 0.35. The probability of both happening is 0.25. So our answer here, the probability of A given B will simply be equal to 0.25 divided by 0.35. Now let's work on calculating unconditional probabilities. As we've discussed, when you simply see a probability of an event without the bar sign, that is an unconditional probability. So the probability of an interest rate increase written as PI is 0.4. The probability of no interest rate increase is written as probability IC, C for complement. So if the probability of interest rate increase is 0.4, then the probability that there will not be an interest rate increase is 1 minus 0.4, which is 0.6. Let's say that the probability of a recession given an interest rate increase, so this is a conditional probability, this is written as PR given I. The probability of a recession given that there is no interest rate increase, written as PR given IC, I complement, is 0.1. So what is the unconditional probability of a recession? The unconditional probability written like this is probability of a recession given interest rate increase times the probability of an interest rate increase plus the probability of a recession given no interest rate increase times the probability of no interest rate increase. Notice that these events, probability of I and not I, these need to be mutually exclusive and exhaustive. So those two conditions, being exclusive and exhaustive, is important, and this rule is called the total probability rule. We have taken a specific example of the total probability rule, but I hope this is good enough for you to understand the concept. Now we'll talk about the application of probability rules that we have learnt, and we will start with the Bayes formula. The Bayes formula allows us to adjust our viewpoint when we receive new information. So let's say that we are tracking a certain event and the probability of that event is given by PE. What happens to the probability if we receive certain new information I? The way we write this is probability of that same event that we were tracking given the new information is equal to the original probability of that event times probability of information given the event divided by the probability of the information. Now I think the CFA curriculum does a nice job of giving an example here which I will describe. So let's say that the probability that you are tracking a company called DriveMed, and they are going to announce their earnings per share next week, and there are certain expectations about EPS, and you think that the probability that earnings per share will exceed expectations is 0.45 based on your research and your knowledge of the company and the industry. Other relevant information is that the probability that the EPS will meet expectation is equal to 0.3. The probability that EPS will be below expectation is 0.25. These are referred to as prior probabilities. Now you get some new information that the company has decided to expand. Now based on this information you decide to update the probability of the event. Basically what you conclude is that since this company is expanding, so they've made an announcement they will expand, most probably the earnings are going to be good, and in fact you believe now that the probability that earnings will exceed expectations will probably be more than 0.45 because why else would DriveMed expand? Now what is the new probability? And let's just look at it here. So as I'm just writing this again to help you remember this. So probability of the event, which in this case is that EPS will exceed expectations, given the new information that DriveMed is expanding, is equal to probability of the original event before you receive the information times the probability of the information, which is that DriveMed is expanding given the event, divided by probability of the information. So what is probability of the event? The probability of the event we were already given is 0.45 times probability of information given event. So let's say that you had evaluated some more likelihoods here, and you had, based on your research, concluded that the probability that DriveMed expands, so this is the information, given that EPS will exceed expectations is 0.75. Similarly, probability of DriveMed expanding given that EPS meets expectation is 0.2, and probability DriveMed expands given that EPS is below expectation is obviously very low and at 0.05. So these are likelihoods that you have determined based on your research. Plugging in the 0.75 over here, so that's this probability of information given event is 0.75, and what we now have to find is the unconditional probability Pi. Pi is now calculated using the total probability rule. So if you recall, the total probability rule tells us that the probability of this information that DriveMed expands is equal to probability of I given that EPS will give probability of I given that the EPS will exceed expectations times the probability that EPS will exceed expectations plus the probability of information given that EPS will meet expectations times the probability that EPS will meet expectations plus probability that probability of DriveMed expanding given that EPS is below expectations times the probability of EPS being below expectations. And what you can do is just plug in the numbers and you will notice that all these numbers are given. So I given that EPS exceeds expectations is 0.75. So this becomes 0.75 multiplied by probability that EPS exceeds expectations is 0.45 plus probability that of the information which is DriveMed expands given that EPS meets expectations, this is 0.2. So plus 0.2 times the probability that we meet expectations is 0.3, and the final one here, probability that DriveMed expands given that EPS is below expectations is 0.05 multiplied by probability of EPS being below expectations, which is 0.25. So now what you need to do is multiply all these out, add them up. That will give you probability of the unconditional probability of the new information. Plug that in here and you will get the probability of E given I, and come up with your answer and then double check this in the curriculum. And then what I want you to do is go through the rest of this example in the curriculum, and that will help you understand Bayes formula quite well. Just as a side point, probability of E given I, which is what we calculated, is called the posterior probability. Also, I would suggest that this Bayes formula, most people have trouble with this, and I don't think it's worth spending too much time on this before you understand all the other concepts. The probability of being tested on this is low, and even if you are tested, then make sure you know this formula, and as long as you understand this example, you are in good shape. But once you've understood the other material in this chapter, then focus on this topic. Okay, another application of probability can be used in an investment tree. Let's take a small example. Let's say that there are two scenarios for our economy. Either there will be a boom or a recession. And let's say the probability of a boom is 0.6, probability of a recession is 0.4, and the stock that you are following, let's say that if there is a boom, there is a 0.7 probability that the earnings per share for your stock will be 1.5, and in the boom situation, there is a 0.3 probability that the earnings per share will be 1.0. On the other hand, if there is a recession, then there is a 0.8 probability that the EPS will be 0.5, and there is a 0.2 probability that earnings will be 0. Now the question is, what is the expected value of the earnings per share? The way you do that is you look at all these possible values for EPS and their probabilities. So what's the probability of EPS being 1.5? That is 0.6, which is the probability of a boom, times 0.7. So the probability is 0.42. The probability of EPS being 1.0 would be 0.6 into 0.3, which is 0.18. The probability of this EPS of 0.5 would be 0.4 into 0.8, which is 0.32. And the probability of EPS 0 would be 0.4 into 0.2, which is 0.08. Now, what's the expected EPS? The expected EPS would simply be 1.5 into 0.42 plus 1.0 into 0.18 plus 0.5 into 0.32 plus 0 into 0.08. So you do all these multiplications, add it up, and you will have your expected EPS, which if you do the calculation should come out to be expected value of your EPS given all these probabilities is 0.97.